Today we are going to discuss about the chemical properties of metals and non-metals. Metals are electropositive in nature. What is electropositivity? We already studied about electropositivity in our previous chapter. Periodic classification of elements. What is electropositivity? The property of a metal to lose electrons and attain a positive charge. This property is known as electropositivity. Generally, the valence electrons, the outermost shell of metals contains 1, 2 or 3 electrons. Lose these electrons to form positively charged ions. Positively charged ions are known as cations. These cations are stable as they acquire noble gas configuration after losing the valence shell electrons. As we studied in chemical bonding. As we know, sodium is a metal. It has 11 electrons and 11 protons. Its atomic number is 11. Sodium loses 1 electron and become sodium ion, Na plus ion, by losing 1 electron. That means it loses 1 electron and have only 10 electrons and 11 protons. That means it has 1 positive charge. So we represent Na plus. This 1 electron is received from chlorine and from sodium chloride. We already discussed. This property is known as electropositivity. This property is known as electropositivity. Loses electrons and become positively charged ions. This is the main property of metal. Metals forms cations by losing electrons. During electrolysis, their aqueous solution they are discharged at the cathode because it is a positively charged ion. On the other hand, non-metals are electronegative in nature. That means it receives electrons and become negatively charged ions. Imagine the similar examples. Sodium chloride. Sodium has 11 electrons, 2, 8, 1, and chlorine has 17 electrons, 2, 8, 7. Sodium loses 1 electrons and become 2, 8. That means noble gas configuration. And chlorine receives these 1 electrons and becomes 2, 8, 8. That noble gas configuration. So attaining noble gas configuration, metal loses 1 electron and non-metal receives 1 electron. Normally, non-metals contains 5, 6 or 7 electrons in their valence shell, outermost shell. That is why they have the tendency to receive electron, gain electron to form octet. Based on this property, electronegativity and electropositivity, metal shows and non-metal shows a wide variety of properties and make a lot of compounds. Remaining electropositivity and electronegativity in your mind. Now we are going to discuss about the chemical properties of metals. First one, reaction of metal with oxygen. Most of the metal react with oxygen and form oxide. Some metals react oxygen without heating. Some metals react oxygen only when heating. We can go through the example. One example is sodium. Sodium react with oxygen to form sodium oxide. Na plus 4Na plus O2 gives 2Na2O. This 4Na, 4 from 4Na and 2 from 2Na2O. These are coming by the process of balancing, chemical balancing, as you already studied. Mg plus O2, MgO. Al 4Al plus 3O2 gives 2Al2O3. Here, sodium react with oxygen without heating, but magnesium react with oxygen only when heating. When we burn magnesium, it forms magnesium oxide. When we put sodium in open air, it reacts with oxygen and form sodium oxide. Oxides of metals are basic in nature. We already studied. And they react with water to form bases. Na2O, CaO, MnGO, etc. etc. We already studied. Sodium hydroxide, calcium hydroxide, potassium hydroxide, etc. etc. But oxides of aluminium, Al2O3, zinc, ZnO, tin, SnO, and iron, Fe2O3 are amphoteric in nature. What is amphoteric? They shows both the properties of acid and base. We already said that oxides of metals are basic in nature, but some metal oxides shows both the properties of metals and non-metals. That oxides are known as amphoteric oxides. Amphoteric oxides are oxides which shows both the properties of metals and non-metals. Example, Al2O3 plus 6HCl gives 2AlCl3 plus 3H2O. Forms salt and water. Al2O3 react with hydrochloric acid, forms aluminum chloride. AlCl3 is a salt plus water. Similarly, Al2O3 react with NaOH, is a base, also forms a salt, NaAlO2 plus H2O, salt and water. So, it shows both the properties of acid and base. Then reaction of metals with acids. Metals react with common acids like dilute hydrochloric acid, sulfuric acid, etc. with the evolution of H2, hydrogen gas. The reaction of magnesium. Magnesium plus hydrochloric acid gives magnesium chloride plus hydrogen gas. Magnesium react with HCl to form magnesium chloride and hydrogen gas. Salt plus hydrogen gas. We already studied. Reaction of metals with water. We can classify the reaction of metals with water in different categories. Many metals react with water to form hydroxides. Normally, hydroxides are basic in nature. Sodium and potassium react with cold water. Listen, sodium, potassium, etc. react with cold water, Na plus H2O, NaOH plus H2. When sodium react with water, produce sodium hydroxide plus hydrogen gas. We just discussed this in our previous section. Metal react with gas, acid to form salt and water. Similarly, potassium also react with cold water. But magnesium react with hot water. Magnesium plus H2O. But this H2O is hot water. Magnesium hydroxide plus H2. Metals like aluminum, iron, etc. react with water or with steam. That means with evaporated water. Aluminum plus H2O, steam, Al2O3 plus 3H2. Iron also react with steam. That we can categorize metals react with cold water, metals react with hot water, metals react with steam. The temperature will be changed. The normal water, cold water's temperature is very low, hot water temperature is high, that temperature of steam is very high. That means we can classify the reaction of metals with water as three groups. Reaction of metals with common bases. Some metals like aluminum and zinc react with common bases. Example, Sn plus NaOH plus H2O gives Na2SNO3. Sodium stannate. Zn plus NaOH. Sodium zincate, etc. etc. Next property is corrosion. Metals react with air and form their oxides. That means react with oxygen to form their oxides. This oxide formation tendency of metals affect their physical and chemical properties. Imagine iron become rusted. As you see in your surroundings, metals, when we put metals in our surroundings, it become rusted. And this rust is formed by the reaction of metal with the oxygen. Then this metal will corrode. It will never return back to original form. When process of oxidation of metal is known as corrosion. Process of oxidation of metal is known as corrosion. When a metal is corroded, it will last forever. That means it's a big loss in our economy. Imagine a ship made with a metal, just like iron. It will become rusted. It will destroy forever. So we want to make another one. As you see in your surroundings, many metal made objects become corrode due to this rusting. Corrosion of metal, iron, we can just express that 4Fe plus H2O plus 3O2 gives 2Fe2O3 H2O. Brown rust. Rusting of iron needs presence of moisture and presence of oxygen. That means presence of oxygen and water. For preventing from rusting, we can make many methods, as you already studied. Painting. When we paint, we can prevent metal from corrosion, because paint protects metal from its surroundings, just like oxygen and water. Oiling and greasing. When we put oil or grease around the metal, it also prevents it from corrosion. Galvanization. Galvanization means put a layer of zinc on metal. Zinc is a metal, and we give a layer of zinc on iron. It is known as galvanized iron. It protects from rust. Alloying. That means making alloys by using different methods. It's a good method to prevent it from rusting. Making alloys. Stainless steel is an example of an alloy. We use stainless steel in our daily life for making utensils, plate, glass, etc. etc. It is made from iron by adding carbon and chromium, nickel, chromium and iron. We make stainless steel. Also we use steel bars. We hear about steel bars, but we never say it is iron bar. We used it to make our home and buildings. We buy iron bar, not steel bars. That means iron is alloying with the carbon. We make a harder one, and it prevents rusting better than iron. Also, you may hear about gold. 22 carats. 24 carat is the amount of purity of gold. 24 carat is the pure gold. We use copper or silver to making alloys to prevent rusting. By using this we can prevent metal from rusting. Just to go through the properties, all these are you already studied.